To do most of the problems in section 2.6, the derivatives of inverses, you do need to know the derivatives of the inverse trigs. Not the integrals, we were talking about those, but these derivatives. And the only difference between the derivative of arc sine and arc cosine is a negative. The only difference between derivative of arc tangent and arc cotangent is a negative. The only difference between derivative of arc secant and arc cosecant is a negative. But you do need to know these formulas. Now, to do these problems, this is from 2.6, we're going to need to use these formulas. The derivative of arctangent, which sometimes is written this way, of u is u prime over 1 plus u squared. What does it appear I'm letting u equal? E to the x. What's u prime? Its derivative is e to the same power times the derivative of the power, which is 1. So u prime is also e to the x. So when I go to fill this in, u prime on top is e to the x. 1 plus u squared, well, what's u? E to the x. So what do you get for your derivative? You always need to simplify these, so a power to a power, you multiply exponents. So that's not e to the x squared, that's e to the 2x. That's for 27, and it's pretty much just straight following the formula. 29 is a quotient, so I need the quotient rule. So I will do the quotient rule here. The bottom times the derivative of the top, u prime over radical 1 minus u squared, minus the top, arc sine of 3x, times the derivative of the bottom, which is just 1 dx dx, all over the bottom squared. I did a quotient rule, u over v. V u prime minus u v prime all over v squared. So pretty much it's just the quotient rule. So let's clean this up. I'll never accept a fraction within a fraction. Don't forget, when you square 3, it becomes a 9x squared there. And this is arc sine 3x, and this whole thing is over x squared. I need to deal with or get rid of this square root. What's the opposite of dividing by that square root? Multiplying by that square root. So I'm going to do this on top, and these will cancel, giving me 3x minus radical 1 minus 9x squared times the arc sine of 3x all over x squared times the square root of 1 minus 9x squared. And that should be dy dx. It's an odd answer. Let me check it in the back and see what they have. Okay, I'm going to try and go in the sequence they were asked. So after 27, 29, I think somebody had asked me 37. Please note that I left a space here because this right here is a product, and I need to use a product rule to find its derivative. I just want to know one question. How did you approach it? Did you use this times this? Or did you keep the 2 out front and just do a product between those two? Okay, so I think we're going to do it this way. I do again believe that the best way is by keeping the constants factored out front. So now I just have the product between two things. X, so I bring the x down, times the derivative of arc cosine, which is negative u prime over 1 minus u squared. Plus the other way around, bring down the arc cosine of x times the derivative of x, which the derivative of x is just 1, isn't it? Dx dx. And close. Don't forget that 2 applies to both of these. So you get negative 2x over radical 1 minus x squared plus 2 arc cosine of x. I still have this thing out here, so I have to do the power base 1 less power derivative of base. I noticed that the 1/2 and the 2 could eliminate each other. A negative and a negative make it plus. So that gives me 2x over, again, the radical, because the negative square negative, and that means a square root on the bottom. Notice that this and this add to 0. So my dy dx is going to be, in simplified terms, 2 arc cosine of x. Okay, 37, how about 43? This again looks to be a product, so I'm going to do a product rule. So derivative of y is dy dx, bring the x down, derivative of arc sine is u prime over 1 minus u squared. Plus bring down the arc sine of x times the derivative of x, which is just 1. Over here I would have power times base to the 1 less power times the derivative of the base. So this becomes x over radical plus arc sine of x. This would be minus x over a radical. This and this would add to 0, making dy dx simply the arc sine of x.